You may have heard or read about Automation Direct's newest programmable automation controller, the Productivity 3000. You might ask, what is it? How does it work? Will it work from my application? And how much easier is it to use than a traditional programmable controller? Well, in this video, we're going to show you the out-of-the-box experience, how easy it is to power and connect up to the new Productivity 3000, configure the hardware, and be on your way to programming your new application. For this video, we're going to solve a hypothetical application. Our application will be, let's say, an assembly machine like this one. For this machine, we're going to need a controller that'll do all of the following: support AC and DC voltage inputs and outputs, isolated relay outputs, a few voltage and current analog input and output signals, communicate directly with a GS2 AC drive, interface to a Seymour touch panel, and the entire system needs to use Ethernet connectivity. Okay, in order to accomplish all of this, we're going to need the following hardware as shown here. Let's get started. Here we have all of the P3000 components in their shipping boxes. Watch as we assemble the hardware prior to connecting any wires. Let me make a quick statement about the terminal blocks on the I/O modules. Most of the I/O modules, you'll need to purchase a removable terminal block like this one. The part number is going to be a P3-RTB. They're not supplied with the modules. Well, we did this because a lot of our customers prefer using our ZipLink modules and ZipLink cables. So we give you the option of which route you'd prefer for your application. And finally, because we have all the I/O modules we require for our application in the first 7 slots, I'll install a filler module in the last slot. The filler module is not just for aesthetics, but it also helps eliminate dust and contaminants from getting into the base. Okay, as you watch me put the modules in the base, it was simple. I just press them into place and lock the tabs on the top and the bottom. I'll show you again real quick. Each I/O module has a tab on the top and on the bottom. You just slide the module into the base and lock the tabs. And if you notice, the power supply and the CPU both have tabs just on the bottom, and it rotates at a 45-degree angle on the top. If you noticed, I didn't worry about which modules I selected or which slot I placed them into. That's because there's no power budget restrictions for the P3000. It was designed to accept worst case scenarios, so no more adding up power consumptions of each I/O module. The P3000 doesn't have any module location restrictions when it comes to placing the modules in the base. Now, of course, the power supply and the CPU both have dedicated slots, but all of the I/O modules can be inserted in any order. Now, here's a tip. Typically, you would lay out your system so that all of your discrete input modules are together and come first from left to right. Then your discrete output modules, analog input, analog output, and if you had any specialty modules like high speed or communication modules, they'd typically be at the end of the base. Now, there's no rule stating that your layout must follow this example. This just makes wiring and programming and troubleshooting easier in most applications. Also, keep in mind that the I/O modules can be hot swapped on the P3000 system. And we go into more detail with this feature and other features in later videos. Well, our assembly machine control system will be using a GS drive and a Seymour touch panel. that both have Ethernet connectivity. It's good practice to extend both the Ethernet and remote I/O ports on the CPU to Ethernet switches to make it simpler to connect to these devices and future devices. Here we've added a couple of our Stride Ethernet switches, and we've provided 24 volts DC power to the switches. Please note that the remote I/O port uses Ethernet connectivity. Our assembly machine will be using an AC motor with the variable frequency drive, so let's get the GS2 drive connected to the Productivity 3000. The P3000 system has the ability to auto-detect GS drives that are connected to the P3000's remote I/O port by the way of a GS Ethernet drive module, or this part number. Here's the GS eDrive 100 module wired to our 24 volt DC power source. The P3000 has built-in software instructions that allow us to both configure and control the GS drive interface through the eDrive. Here we connect the supplied black cable to the GS drive and back to the eDrive. For your reference, there are switch settings and configurations that are required on the GS2 AC drive and the GS eDrive module that we'll cover in future videos. It's a simple matter of powering our Seymour touch panel with 24 volts and connecting an Ethernet cable between its Ethernet port and the Stride Ethernet switch, and the Stride Ethernet switch is connected to the CPU's Ethernet port here. Okay, our hardware is configured. Now we'll apply power by wiring up 120 volts AC to our P3000 power supply. Well, we've wired up a few I/O points now to show the connectivity and how simple it is to use the programming software to identify the I/O and add them to our program. Well, what I did is I've wired up a limit switch in this box here to an input module. I've used the normally closed contact on the limit switch because I want a signal back to the P3000 when the switch is not being actuated. Next, I connected a stack light to one of the output modules on the P3000. Again, our intention in this video is to show how easy you can get the P3000 out of the box, assembled, connected, and programmed. We apply power to the CPU and we connect the communications cable. Now, if you've programmed PLCs in the past, you're used to having some type of proprietary or special made cable for communications. Well, not anymore. In the past few years, what has been the most popular type of communications? USB. I even have USB on my cheap car stereo. Most new PCs have several USB communications ports. Well, guess what this is? It's USB. Simply connect the P3000 with a standard USB cable, and it doesn't get any better than that. We'll continue with our out-of-the-box experience in part 2 of this video by showing how simple it is to use the software to configure the hardware, and then we'll program a simple rung using tag names. Thanks for watching. See you soon.